Hello guys, welcome back to the Civil Engineering YouTube channel. Please subscribe our channel for daily civil engineering videos. Today our lecture is about the frame analysis. So in this topic we will be going to discuss some different types of the frames, and I will show their deflected shape and their analysis, how we draw the deflected shape of these types of the frames. This you can see here at this only the concentrated load acting on this frame. Here you can see the uniformly distributed load and acting on this frame, and they have different support conditions while this frame has different support conditions. So I will draw the different deflected shapes according to the different types of the frames. So to draw the deflected shape of any type of frame, you must remember these 2 points. The first one is that the deflection angle remains unchanged. I will explain this by drawing the deflected shape of each type of frame, so you will get to know what it means. But you must remember that the deflection angle must be constant. The second one is the deflection, no deflection at the nodes. What is node? The point where the two member joins, like this is a beam, this is a column. So this point joint is known as the node. Alright, we call it the node. So there will be no deflection at nodes. By applying these 2 conditions on any type of the frame, you can draw the qualitatively the deflected shape of any type of frame. And then according to the deflected shape, you can easily find the reactions and the shear force bending moment. And this is called the node point of this frame. This is called the node point of this frame, where the different types of the members are connected. We call this point as the node. Now to analyze this frame, first of all, we should know that this is a pin support, hinge support. So what is the property of the hinge support? That it can resist the vertical force, right, as well as the horizontal force, but it does not resist any moment. While it does not resist any moment, so there will be rotation at this point. You should know that this is a hinge support, so it does not resist any moment. So due to the load, this will show the rotation, this point. While here we can see here is a fixed support, it resists the horizontal, the vertical, as well as the movement due to the fixed support. So there will be no deflection, there will be no rotation at such point, at this point. So to draw its deflected shape, first of all we should know that the load is acting at the node. So the no deflection is allowed here at the node, as you can see here. To apply this point here, so due to load, it will deflect like in this way. So this point will show rotation. This is the rotation Q, because the hinge support does not resist any movement. So it will show slope, or it will show rotation at this point. While to manipulate this one, what should we do? The deflection angle remains unchanged at this point. So how we draw it? We should draw it like in this way. There is a fixed support, so there will be no rotation here, but it will move like in this way. So you can see here now that the angle which was 90 degree before, between the two, this was the 90 degree angle before, it remains constant now, because this beam deflected in the same angle as this one. So this angle remains 90 again. So we can say that the deflection angle was remain unchanged here at this point due to the deflection of this frame. You must keep in mind that first of all you should know the type of the support condition, and then the load where it is acting. Then there will be no deflection at the nodes, so the node will be the fixed point, and the other one is the deflection angle should be constant. So if your column deflects in this way, you should rotate your beam in this way, so that the angle between these 2 members remain constant. While before it was 90 degree between these 2 members, so again after deflection the angle remains same. So there was no change in angle. Now this was the first one, to draw the deflected shape of this type of frame, in which we have 2 fixed supports. So due to this uniformly distributed load, it will not show any rotation here. So this will be the fixed line, like, and it will show like this one. So the angle between this column and beam was 90 degree, so due to which this will also go into the 90 degree, and it will like fixed. There will be no rotation at this point. There will be no rotation. due to the support condition. There's a fixed support, so no rotation is allowed. Only the resistance will be provided in vertical direction due to the load is acting in the vertical direction. So no deflection, no rotation at the supports, while it will deflect only at these points. And the angle must keep 90 degrees. So this is the qualitatively deflected shape of this type of the beam, of this type of the frame. The next one is if the load is acting horizontally to this beam, so the deflected shape will be like this, the hinge support, so there will be no horizontal and vertical displacement, so it will move like in this way. Now, to make the constant angle, like these two members have 90 degree, so to make it 90 degree, this frame will deflect in this way. Now again, the angle between these two members is 90 degree. So this is the qualitatively deflected shape of this frame, and you can see when the load is acting horizontally to this beam. Now I will draw the deflected shape of this last frame. So this frame is like a complicated one. You can see three different supports: fixed support, and the hinge support. So the hinge support will not resist any movement. So according to the load, it will deflect and will show rotation here at this point, right? Because there's a hinge support, so there will be rotation at this end. Now, due to deflection of this beam, due to deflection of this column, the other beam will also show deflection. Now, to draw the deflected shape of these two beams, we will follow this rule that the deflection angle remains constant. So the angle between these two beams was 90 degree. So according to that, this frame will also rotate in this way now. So this angle between the deflected shape is now against 90 degree, constant. So according to that frame will deflect in this way. Now the angle between these two members is again 90 degree. And this one is 180 degree between these two. So we have the same angle after rotation. So this is the qualitatively deflected shape of different types of the frame. You can draw any deflected shape of any type of beam according to your support condition, according to your loads, but you must remember these 2 points. The deflection at the node should be 0, like there will be no deflection at the nodes where your two members connected. And the other one is the deflection angle must remain unchanged, where your deflection angle should always be constant in your frame analysis. So this was all about the frame analysis, and don't forget to subscribe my channel for more civil engineering videos. Thank you for watching my video.